Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at assignment number 7. Assignment number 7 is found on page 362, numbers 1 through 45 odds only, then numbers 61 and 63. And this is from 5.8, Inverse Trigonometric Functions Integration. So I'd like to just begin by pointing out to you the formulas that we're going to be working with. The integration of du divided by the square root of a squared minus u squared equals arc sine of u over a plus c. The integration of du divided by a squared plus u squared equals 1 over a arc tangent u over a plus c. And then the integration of du divided by u times the square root of u squared minus a squared equals 1 over a arc secant absolute value of u over a plus c. Now, a lot of people don't know where these come from, so I'd like to just take a minute before we actively begin so that you can see where we got these. All right? Now, in order to do the first one, what we're going to do is we're going to use our reference triangle, and that's going to make this understandable. So if I use a reference triangle, the first thing that I notice is that I have an a squared minus u squared. Now, a is the constant and u is the variable. So what you're going to do is you want your constant to be the hypotenuse. Now, our variable can then either be cosine or sine. And we're going to be very strategic about this, and we're going to let this always equal sine of u over a. See, now by doing that, what's going to happen is I have the sine of theta is u divided by a. But that means that a is the sine of theta, and that's u. And a cosine theta has to be du. Once again, just taking my derivative. Here's the issue. If we look at this, I have a missing side, and I need to find what that side is. Well, that side is the square root of a squared minus u squared. And you'll notice that's what we have in our denominator. So by setting up a quick ratio of sine or cosine or tangent, I should be able to see something that I can work with. Let's take a look. If I look at the square root of a squared minus u squared, which is my adjacent side of theta, divided by a, the hypotenuse, I am looking at the cosine of theta. That means that the square root of a squared minus u squared is a cosine theta. And just as we saw in our previous sections with u substitution, I can now substitute pieces. But instead of it being u, it's going to be a trig function. Think about that one. So let's look at how this is going to work. The integration of our du. That's a cosine theta, and I did forget the d theta here. I'm going to put that in. After all, it is a cosine theta d theta equaling du, written as a differential. Now, our denominator is the square root of a squared minus u squared, which I have identified as a cosine theta. Notice that now I'm only left with d theta. And we know that this is theta plus c. All right, well, what's theta? It's right here. I'm going to take my arc sine on both sides to find theta. The arc sine of u over a. That's now going to go in place for theta, and I end up having arc sine u over a plus c. And that's where it came from. Now, all of these are following the same basic pattern as this. For a squared minus u squared, we use the sine of theta equals u over a. If I'm working with the tangent, or a squared plus u squared, I have the tangent of theta, and we have u over a. And please always make sure that u is in the numerator, please. And then for this one, we're looking at the secant of theta, and this is going to be u over a again. Okay, so just be aware, this is what we're looking for, and this is what we have. Hang on a minute, I've got it backward. I'm just double checking my work. You notice I've got u squared minus a squared. That's going to be a over u. This is one of the reasons why we're going to need to have that absolute value. Okay? Okay. So with this information, we're now going to use this right here to answer our questions in our homework. Let's go ahead and begin now. So we're starting off with the first question. And the first question gives me the integration, and I have the square root of 9 minus x squared and a dx. Well, I could always go and set it up using this right triangle, which will give me what I want, and it'll come out as an answer like this. Or I could just do direct substitution. This is 3 squared minus u squared, which means that I have the arc sine of u over 3 plus c. Now that's the easiest way to get this answer, is a direct substitution, but you can, if you so choose, go through this reference triangle. I recommend you don't, especially for the AP test. That's just reinventing the wheel each and every single time. Frankly, it's more important that you memorize these formulas before we go much further. Now let's go to number 3, please, as we are doing the odds. So in number 3, I am looking at the integration. I have a 1x square root 4x squared minus 1 dx. Now I'm looking at this as 2x, the quantity squared, minus 1 squared. And you'll notice that if I want my dx on top, I should have a 2 up there. Right? Look, what's the derivative of 2x? A 2. 2 dx. I don't. You'll also notice that according to my formula, I should have u times the square root of u squared minus a squared. I should have the same thing here. Now the way we deal with this, we multiply by 2 over 2, and now I can say that I have 1 over a, which is 1 over 1, times the arc secant, absolute value, 2x over 1 plus c. And I'm going to simplify that to the arc secant, absolute value 2x, plus c. And that's my answer for number 3. Let's go ahead and go to number 5 now. Number 5 is giving me the integration. We have the square root of 1 minus x plus 1, the quantity squared, and we have our dx. 1 squared minus the variable u squared, and I know I'm working with the arc sine. Arc sine, and I'm going to have x plus 1 divided by 1 plus c. Rewriting it as arc sine of just x plus 1 plus c yields the answer. And there's number 5. Let's go ahead and take a look at number 7, please. Number 7. We have the integration 1 over the square root of 1 minus t squared dt. They just changed the variable. We can still see we have 1 squared here. We can still see that this is t squared. It's a minus, so we're looking at an arc sine. And I have t over 1 plus c, and my answer is the arc sine of t, the quantity plus c. There's number 7. Let's continue to number 9, please. So in number 9, we have the integration of 1 over t to the 4th plus 25 dt. I can see that this is t squared, the quantity squared, plus 5 squared, and it is in the sum form, so we're looking at 1 over 5, the arctangent of t squared over 5 plus c. That's all I'm doing is plugging it in directly into the formula that we've already identified. Let's go ahead. That was number 7. We're going to go to number 9 now and continue as we do. Oh, pardon, that was number 9. I accidentally did number 9 before number 7. Oh, I did number 7 already. Gee whiz. Got lost. Here we go. Number 11. Number 11, we have e to the 2x, denominator 4 plus, and we have e to the 4x, and then our dx. All righty, so what are we looking at? Well, this right here is 2 squared. This piece right here is e to the 2x squared, and it's a plus, so we are looking at an arctangent. And you'll notice that the derivative of e to the 2x is 2e to the 2x. All right, so if I'm working with this, we're going to be looking at an arctangent, and I know I have a 1/2, and then I have the arctan, and I have e to the 2x divided by 2. Don't forget your plus c. And let's just see how that goes. And I believe I have that one correct. Now, I am going to check my answer as I do these. After all, the last thing I want to do is cause a problem for you where you are getting the wrong answers. And like you, I still work with these. I mean, nothing different. As a student, I do problems and I try my best to get them right. And I look for areas where I can improve. And right now I'm just looking at number 11. And indeed, I need the 2. So when we take our derivative, we should get a 2. But in order to do that, I have to have another half so that I have an equivalent form of 1. And that is going to force me to put a 4. I knew there was an issue there. And I had to go back through and work through it. Okay? So let's just be careful. We go to number 13. Number 13. Number 13 says the integration, and we have secant squared x, and I have the square root of 25 minus tangent squared x. I have a dx back here. Now, as I look at this, I say to myself, well, what is my derivative? So I've got 5 squared minus tangent, the quantity squared, and I'm looking for the derivative. If this is my u value, I need to have a du. And du is going to end up being the secant squared x dx. So that was what I was talking about up here. I had to get that 2e to the 2x, which is the derivative of e to the 2x. Once I know this, I can now see I have secant squared x dx. That's the du. And so I am now looking at my du and the square root of 5 squared minus u squared. This is my arc sine. And I have an arc sine of tangent of x divided by 5 plus c. There's 13. Let's now go ahead and take a look at 15. Number 15. We have the integration. I have a 1 square root x, and then I have the square root of 1 minus x, and a dx. All righty. Notice this is 1 squared. Here's the trick. This is the square root of x, the quantity squared. And if I take the derivative, I get 1 over 2 root x. Notice there's no 2 here. That means that I want to put a 2 in front and a 2 on top. Now I can go ahead and look at this as my arc sine 2 arc sine of square root of x divided by 1 plus c for 2 arc sine root x plus c. Once again, take a moment. Let's look over our work, make sure that it makes sense and that we haven't missed anything. Very easy with these extra factors. Looks like we've done good. I see nothing wrong. So I'm going to move to number 17. Now it's to your advantage to double check as you do these. Otherwise, you will find life difficult. Alrighty, let's look at this one. X squared plus 1. Uh-oh, I have 2 terms. I have to separate my terms and create 2 different radicals, or integrals, excuse me. The first, x squared plus 1 dx, this uses a straightforward u substitution. X squared plus 1 du 1/2 is x dx, and so I can go ahead and finish this as 1/2 du and a u. This is 1/2 the natural log. Let's make sure you can see it. Absolute value of u. And then I go to the next piece, minus the integration 3 over x squared plus 1 dx. I'm going to want to move this out. So I have a 1, and there went my lights. Thank you, Alameda Unified School District, for such a useful tool that we have. All right, now this is my arctan. So I have 3 times 1 over 1 arctangent of x over 1. And then I have plus c. I'm going to now add that. 3 arctan of x plus c. The last step is to back substitute the u. 1/2 natural log absolute value x squared plus 1. Now because this is an x squared plus 1, it can never be negative. The absolute values are no longer required if you can't get a negative result. Minus 3 arctangent of x plus c. And this right here is the answer that we are looking for in number 17. Alrighty, let's keep going. We're now going to number 19 as we continue through our homework assignment. Number 7. Now number 19 is the last of these, and then we will be going to definite integrals in part 2. Now be aware, I may end up doing part 2 at a later date, so don't get bent out of shape, please. It will be up by Monday in time for you to do this assignment. And I've got an x plus 5. So here we go again. I have to go through and I have to do this. Now we want to be very careful. After all, as I'm looking at this, I'm going to have this as an x, square root 9 minus x minus 3, the quantity squared dx. And I've got plus 5. And if this doesn't work, I'll try something else. 9 minus x minus 3, the quantity squared dx. Let's see. Trying to figure out, now I think I may have to rearrange this and make this an x minus 3. Now let me show you why. If I FOIL this out, I have x squared minus 6x minus 9 plus 9. I'm distributing the negative. That's going to give me the 9 canceling. See how the 9s are going to cancel? And I have 6x minus x squared. And if I take the derivative of this, I get negative 2x dx and a 6. I'm very close, but not quite. So what I'm going to do is I'm going to actually construct this by simply adding 3 more. So if I add, I have to subtract. I'm going to go x minus 3, and now I'm looking at a plus 8. I'm going to work with this and that. 2 separate problems. The first one will use this, where I can factor out the negative, and I have a 2 that I need to work with. So here we go. I'm just writing down my problems so that I can see exactly what I'm working with, and I now have an 8, and I have this square root 9 minus x minus 3, the quantity squared, and my dx. All right, now I can begin. All of this was just trying to figure it out so that I could work through it. Here we go. I'm now going to take 6, u equals 6 minus 2, the 6x, excuse me, let's try that again. It's 6x, x squared is what I want. So I have u, this was 6x minus x squared. Now it's set up, 6x minus x squared. I'm taking my derivative to find du. I end up with 6 minus 2x dx. I'm going to want to divide everything by 2, so I have 1/2 du. This is then going to give me 3 minus x dx. It's very close. I have to factor out a negative. And I now have x minus 3 dx. Now I can substitute that piece, and I'm looking at negative 1/2, the integration. It's now du, and the denominator is u to the 1/2, and I move to the second piece. Now, since this one is set up as our arc sine, I should be able to use arc sine without any difficulty. Let me go ahead and keep going here. This is going to give me negative 1/2, the integration of u to the minus 1/2 du. This is going to turn out to be 8 arc sine of x minus 3 over 3 plus c. I add 1. I divide by the new power. The new power is 1/2. So I'm looking at negative u squared, u to the 1/2 power, excuse me, plus 8 arc sine x minus 3 over 3 plus c. And I want to back substitute with my u. So let's find where our u was. It's right up here. So I now have 1 square root 6x minus x squared plus 8 arc sine x minus 3 over 3 plus c. And this would be the answer that I would expect. However, I will point out, we already identified that this right up here turned out to equal just that. So I could, if I so chose, to rewrite it as the square root of 9 minus, and then my x minus 3, the quantity squared, plus 8 arc sine of x minus 3 divided by 3 plus c. And please be aware, both of those answers are possibilities. Okay? And that was number 19. That's the end of my first part 1 for assignment number 7, working with the inverse trigonometric functions with integration. I hope this has helped. I will be putting part 2 up as soon as I can. So bear with me if you're trying to do this and you find it's not there yet. Thank you very much, Hornets. And please remember that it is easy to be mean. So please try to be nice to each other instead. I realize it's more difficult, but if you really want to try to be kind to each other. Not just nice, but be kind. Remember, change starts from within. Thank you very much. Be safe and be well. Have a wonderful day. Bye-bye, Hornets.